Our topic today is estimating and rounding integers, positive integers in particular. Now, you may be familiar with the idea of rounding or estimating, but I want to use a couple of examples to talk about why this is important to us. The first one is, let's say that we started out with this number, 93126,493 miles. 93,126,493 miles. Now you may not know it, but that number is approximately, or an estimate of how far we are away from the sun right now. Okay? We might be closer, we might be further away because the Earth doesn't stand exactly the same distance. And of course we can't really literally measure to the center of the sun. It's a little hot, tape measure, it all burn up. Okay? Plus, we don't really want to write down that many numbers or have to talk about that many numbers when we talk about the distance. Well, the sun is 93,126,493 miles away from us. It's easier just to say 93 million. It's an approximation or an estimation. It's not exact, but it's close enough for what matters. If we were to ask how much revenue is there going to be from the Australian Open tennis tournament this year, we might estimate that that number is going to be something like $8 million. Will it be more? Will it be less? Might be a little more, might be a little less, but for the purposes that we need, that estimate's close enough. You see this all the time with sporting matches. Let's say you go to a baseball game and you look at the numbers and they say, yes, there were 55,000 people there today. Was it exactly 55,000? Probably not. Maybe a few more, maybe a few less. Unless they've sold every ticket in the place and every seat's full and they know that, they don't actually know exactly how many, and it doesn't really matter. We're just looking at approximate numbers. Now, as we talk about this idea, there is one symbol that is important for us to learn. Actually, two symbols that mean the same thing. One is this sort of squiggly equal sign, looks like that. The other one looks like a division sign and an equal sign that kind of got together, okay, that mixed with each other. Equal sign with dots on the top and bottom. And those both mean approximately equal to. Approximately. Not are equal to, but are approximately equal to. Now we can estimate answers to problems often by doing what's called rounding. That's the term we need to know today, rounding. Rounding, and we can round numbers to the nearest 10, or the nearest 100, or the nearest 1,000. So let me give you a couple of examples of what I'm talking about. Let's say that we had these two numbers, this number rather, we had the number 83. Now, if I wanted to round that to the nearest 10, it's got to be between two numbers. It's got to be between 80 and 90. Which number is it closer to? Well, it's closer to 80, and so we would round it to 80. Let's say we had the number 776, and we wanted to round that to the nearest 100. Well, my choices are going to be either 700 or 800. It's between those two round hundreds. Which one is it closer to? Well, it's closer to 800. So we round it up to 800. There are lots of examples, obviously, but that's a couple there for you. When we think about rounding, we think about it this way. We look at the last digit that we're dealing with, or the digit that we're dealing with, and if that number is 0, 1, 2, 3, or 4, then we round it down, or we leave the number just the same. So these go down, and 5, 6, 7, 8, 9, those numbers all go up. Now we're going to do some more examples of these at another time, but for today I want to give you an example of give you a couple more examples. So let's say, for example, that we wanted to round 86 to the nearest 10. Well, to the nearest 10 means the 80s, and so we look at that next digit, it's a 6. So that means we're going to round that number up, and it's going to be approximately equal to 90. Similarly, if I had the number 4142, and I wanted to round it to the nearest hundred. Ones, tens, hundreds, that's this place. So I look at the next digit, it's a 4, so I round it down to just 4,100. This becomes 4,100. Now, quite often when we talk about rounding, students don't really understand how they can use this. And one of the key uses is to get some sort of an idea of where the answer should be to a problem if you estimate it. So let's say, for example, 42 times 7. Now, you may not know what the answer to 42 times 7 is. You may be able to figure it out in your head. But what's more important is we can round this number 42. What's it nearest to in tens? What's nearest to 40? And then that's pretty easy to multiply because 4 times 7 is 28. And we add a 0 and it becomes 280. That's not equal to 280, but it's pretty close. You can get some sort of an idea. Let's try a different one. Let's say that we have 95 times 326. Now, if we wanted to do this problem, we can estimate it in a couple of different ways, but we're going to make it as simple as we can. And we're going to round both of these to the nearest 100. 95 isn't 100, but it's pretty close. And if we rounded 326 to the nearest 100, then we would get 300. And what does this give me? Well, 1 times 3, I think you can do that. That's a 3. And then there's 4 zeros on it. So we know that this is not equal to, but it's approximately equal to 30,000. Okay? So if whenever we actually do this problem, we don't get a number about 30,000, then we've probably done it wrong. Now, I'm going to give you 2 more examples. I'm going to round this problem to the nearest 100. To the nearest 100. So approximately, that's about 100. And this is about 100. Multiply 100 times 100 and we get 10,000. Which means that 115 times 92 is approximately equal to 10,000. We can also do this with tens. Let's say we wanted to say 2266 times 9, which looks like a bit of a pain in the neck of a problem. But what we're going to do is we're going to round it to the nearest 10. Well, 10 is here. That 6 tells me I round it up. It becomes 2270. And 9 is almost 10. Nearest 10 would be 10. 2270 times 10 gives me 22700. So this number is approximately 22,700. Now we can characterize these in a couple of different ways. We can either say, I want them rounded to the nearest 10, or to the nearest 100, nearest 1,000, nearest 10,000, and so on. We can also use a term called leading digit estimation. And what that means when we're doing leading digit estimation is we're rounding them off to whatever the first number is. So I'm going to use these examples. If we said I wanted to round 115 off to the leading digit, then it's going to be approximately equal to 100. If I wanted 92, and I wanted that rounded to the leading digit, well, that 92 says we're going to round it down, so it's going to be approximately equal to 90. Maybe we have 2266, leading digit. Leading digit is the 2. The 2 that follows said I round down, so it becomes approximately equal to 2,000. I'm going to do one more example, because I don't want you to get too confused by this. Let's say that I had 884. Leading digit is 8, but this 8 tells me I'm going to round it up. So this is going to be approximately equal to 900. And that is estimating and rounding positive integers.